Alright, so all the videos we've done so far, limits and tangent line, have all led us to this big idea called the derivative. Next year, if you take calculus next year, if you are going to be a senior or junior and you're taking calculus next year, the entire first semester is the derivative. And we work with it and do a ton of things with the derivative. So this is a good video for you to kind of get in a sense of what we're going to be seeing over the beginning months of next school year. Definition: the derivative of a function f of x is the equation for the slope of f of x at any point. It is imperative that you understand that the derivative is an equation. It is not just a number. When we did problems in the last video, we were getting a number. We were actually getting the slope. We calculated something and we got the slope to be -2. We got the slope to be 12. In this case, we're not going to get a number. We're going to get an equation. The difference between this and what we did in the last videos is x is not going to change. When we take a look at the equation down below, limit as h approaches 0, that x, specifically the two x's here and here, they're going to stay x. They're not going to turn into a number. Everything else is going to work the same way, and we'll see that in a second. Also note how we symbolize the derivative right here. Well, let's do that in black. Right here. That is the derivative of f. We read this as f prime of x. Okay. If that were function h instead of f, it would be h prime of x. If our function were Optimus, it'd be Optimus prime. Transformer, that's where you laugh. Excellent, excellent. Okay, so we have our derivative equation. What we're about to see is that everything that we just did in the last video isn't going to change except for what our final answer looks like and what our final answer means. So let's take a look over on the right side of this page, board, whatever. Let's take a look at an example. And we wave the magic wand, and there's our example problem. Find the derivative of the function f of x is equal to 8x squared plus 3x. Now, this is different than when we were working on the problems in the last video, because in the last video it asked us to find the slope of a tangent line at x is equal to 3, or at x is equal to -7. In this case, notice there is no at x equals, because we're trying to find an equation. We're not trying to find a specific number. We're going to work through the process the same way that we did when we were trying to find a number. The difference is we're not going to change x. So when we try and find the derivative, instead of writing m equals, because m is slope and m slope means a number, f prime is a function, and that means it's an equation. Now, it's possible for the derivative to just be 28. It's possible that the derivative is a number, but most of the time it's going to have an x in it in some fashion. So our derivative is simply going to be this limit that we worked on in the previous video, the limit as h approaches 0 of f of x plus h minus f of x all over h. Our job is to just plug it in and then work through this limit the same way we've worked through the limits in previous lessons. So, as we work through this, the first thing we need to do is we need to find f of x plus h. This is where students tend to run into issues, and this is something that I don't understand why we would have an issue with. In the last video, or a couple videos ago, we saw that if we wanted to do f of 12, we plug 12 in for x. If we wanted to do f of triangle, we put a triangle where x is. If we want to do f of smiley face, we put a smiley face where x is. We want to do f of x plus h. So I'm going to do that portion in yellow. Hopefully we'll be able to see it. If not, just turn your brightness down or up and you'll be all good. F of x plus h just says to replace all of the x's with x plus h. So the 8 is going to stay an 8. Instead of x squared, that x is going to be replaced with an x plus h. So now we have 8 times x plus h squared, and then we have plus 3x. But that x is going to change. What's that x going to change into? That x is going to change into x plus h. So there's the first part of our limit. That is f of x plus h. From here, then we have to subtract f of x. Not f of 3 or f of 12 or f of 17, f of x, just the function itself. Well, what's our function? Our function is 8x squared plus 3x, so we're going to have to subtract that entire function. Notice I threw it in parentheses, because if you don't put it in parentheses, you're not actually subtracting the whole thing. Anytime you have a sum or a difference, it's a good habit to put it in parentheses in math, because if you put all sums and differences in parentheses, you'll never go wrong. All of that is still over h. And so this is what we have. Now, to evaluate a limit, the way that we've been doing them over the past few videos, you always want to try and plug in h. In this case, we're plugging in 0 for h. If you did that, the first parentheses would just be x squared, so we'd have 8x squared, which would subtract out the 8x squared. Likewise, we would just have 3x in the yellow, and we have 3x in the green, and those would be subtracted, and we'd get 0 in the numerator. And the reason why is we will always, always, always get 0 over 0 when you try and plug in h right away. We have to go through all of those skills that we learned in previous videos and in previous practice problems that you've hopefully worked on that allow you to evaluate these limits. The way we want to evaluate this one, anytime you have parentheses, especially with exponents, you're going to want to multiply it out. That's usually a good place to go. And so we have to multiply the entire numerator out, get rid of all the parentheses, distribute, and be good to go. And so here's what we get when we do that. All right, so I multiplied it all out. All I did is distribute a bunch of the things that needed to be distributed. I did x plus h times x plus h, and then after I did that, I distributed the 8. I distributed the 3 into the x plus h parentheses. I distributed the negative sign into the green function, and that gave me my entire numerator, no more parentheses. Still, if you plug in 0 right now, trust me, you're going to get 0 over 0. You could always check it, but trust me, you're going to get 0 over 0 until the h in the denominator goes away. There's no point in plugging in anything for h at this point. But we do have like terms, and we can put those like terms together. So we have, let's see, we have 8x squared here and 8x squared here. Those subtract out and are gone. We have a 3x and a 3x. Those subtract out and are also gone. So what we have left, nothing else is a like term. So all that we have left is a 16xh. We have an 8h squared added to that. And then we have a 3h added to that. And all of that is over h. Still, if you try plugging in that 0, you're going to get 0 over 0, as I just mentioned. Until until the h in the denominator goes away, there's no point in plugging anything in. It's just going to give you something that's not going to work for you. If we look at our numerator now, they have one thing in common. Every single term has an h with it. This should always happen for you when you're doing like polynomial stuff. If it doesn't, you probably did something wrong. If I factor the h out, that'll leave me with a 16x plus 8h because I only removed one of the h's, plus 3 because I removed its h. And all of that is over h. And the reason why we want an h to factor out, and it's got to, is because that h in the denominator has to go away in some fashion, and this is usually the way that it goes away, by canceling out. In doing so, we end up with a very, very easy limit now that we'll be able to do. We have the limit as h approaches 0. Notice I'm still writing that until I plug 0 in for h. I can't not write that. And we have 16x plus 8h plus 3. I forgot my x. 16x plus 8h plus 3 is what we have left, and now we can evaluate this limit. Now you have to be careful. A lot of students will just plug in 0 for every letter that they see. That's not how math works. It says h is going to 0, so h is the only thing that can be 0, so if we plug 0 in for h, 16x is still going to be a 16x because I don't plug anything in for that. 8h turns into 0, 8 times 0, and then the plus 3 doesn't have an h. And so there we go. We have just figured out the derivative of our original function, 8x squared plus 3x. The derivative is 16x plus 3. Notice it's an equation. It's not just a number. So how are we going to use this? We're going to use this to do the next part. So what I'm going to do is I'm going to go to the next slide. I'll copy this over to the answer, at least over to the next slide, and we'll see how we use it. All right, so here on the next slide, I just copied over the function and its derivative. 8x squared plus 3x was our function, and the derivative we found is 16x plus 3. Find the slope of the tangent line. I have 3 different ones to do. Find the slope of the tangent line at x is equal to, first, 3. Okay, no problem. If we did this problem on the last video, what we would have done is we would have done the limit as h approaches 0, and we would have replaced the letter x with 3. So we would have had f of 3 plus h minus f of 3 all over h, and we would have done that whole limit basically the same way we did it on the last slide. However, now that we actually have the derivative, what we can do is we can just say what we're really trying to figure out is f prime of 3, because we have a function that will give us the slope now that we've done all the work. So we can just do 16 times 3 plus 3, and that ends up equaling 51. Super duper easy. Now, we had to do the work anyway, so you might be thinking, well, let's just do the work when plug in 3 and it's no big deal. This way we don't have multiple variables to deal with, etc., etc. Well, here's why we want the derivative. To do part B, if we want the value of the slope at -7, we would have had to go through and do the entire limit all over again, doing all of those steps, plugging in -7 for x instead of 3, and then we would work it through and get our answer. Instead, we can simply go, oh, I have the derivative. I can do 16 times -7 plus 3, and that equals -109. Easy. No problem. To do x at 100, to do the slope at 100, super duper easy. I don't have to do another limit or anything like that. I can simply just plug 100 into the derivative and do 16 times 100 plus 3 and get 1,603. So this is why we do a derivative. A derivative allows us to find slopes at multiple points without having to do the limit over and over and over again. So let's take a look at one more example, and then we should be good to go. All right, so for this problem, we're finding the derivative and the equation of the tangent line for f of x equals the radical x at the coordinate 9, 3. So that coordinate 9, 3 is not going to come into play until we're doing the tangent line portion, because remember, if you're going to find a line, you need a slope and a point. So we have the point, we just have to get the slope. When we did this in the last video, we got the slope by doing the limit as h approaches 0. When we would plug in this 9, we'd plug in for x. The 3 wouldn't play at all, but the 9 we'd plug in for x. We're not going to do that here because the problem's asking us to find the derivative. And so that's what I'm going to find first. I'm just going to find the derivative by doing what we just did. The derivative, f prime of x, is going to equal the limit as h approaches 0. Now we know it's going to be f of x plus h, and so our function f of x is the square root of x, so f of x plus h would simply be the square root of x plus h. Minus the function f of x, the function f of x is the square root of x, and all of that is over h. We've seen limits like this with square roots. We did one like it in a previous video. What we need to do is multiply by the conjugate. So I'm going to go ahead and multiply the numerator and denominator by the conjugate of the numerator. So I'm going to multiply by radical x plus h plus radical x in both the numerator and the denominator. That blue fraction that I'm writing is equal to 1, so I'm not changing the function at all. When I do that, I get this. Boom, by multiplying the numerator out, we just get x plus h minus x. You just have to do the distributing, and then the denominator, the h just multiplies that denominator. The nice thing is, those x's in the numerator will cancel out. They become 0, and then we have an h that also cancels out, so putting those steps in as 1, we end up with the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Once that h is gone, I can now plug in 0 for h, so I don't need the word limit anymore, and when I plug in 0 for h, I get 1 over the square root of x plus the square root of x, which is really 1 over 2 radical x. That is the derivative. Once we've got the derivative, now we can go ahead and find the slope. And so to get our slope, m, we want the slope at 9, 3. Our slope then is just going to be the derivative evaluated at 9. And so that's going to work out to be 1 over 2 times the square root of 9. The square root of 9 is 3, and 2 times 3 is 6. And so our slope is 1 over 6. And so our final answer is... So there's our final answer. Y minus 3 equals 16x minus 9. And there's your practice for this assignment. This is the way you need to do all these problems. Make sure you're doing them correctly, because you won't get credit if you're not doing them the correct way. If you find newfangled ways to do derivatives, save them for another time. Make sure you're doing it my way. You need to practice this limit thing. Until next time, have a great day.